My name is William Tadekawa, and my senior project is on robots in society. How do robots affect our lives today? The cars and computers many of you have are all built by robots. Why robots? Ever since I watched the movie Short Circuit 2 during elementary, I've had a deep interest in robotics. I really enjoyed how the movie portrayed a friendly robot with human-like emotions. Three main topics I'll cover in this presentation are the research paper, fieldwork, and learning stretch. First, I would like to talk about my research paper. The title of my research paper was Robots, Extra Helpers in Society. In this paper I cover three main categories: assistance, rescue, economy, and also their controversies. As you can see, assistance robots cooperate with humans to accomplish tasks, and rescue robots save lives. Robots can also help our economy because they do not need salaries or lunch breaks and can work all day long without losing efficiency, leading to lower product costs. However, there are some controversies concerning unemployment and control. Singularity is a concept where humans become unable to control the robot's actions. Fieldwork. Community mentor is Mr. Hilton, who is very caring, intelligent, and highly experienced in the physical sciences. This is a design process I went through to complete my final product. This first picture have a basic structure of the robot with tank treads, two motors, and some gears. The second one, I added on another motor and two more gears to allow movement to the elbow joint. This picture is the gripper with two motors on each side to allow opening and closing movement. Here I attached the gripper to the robot. This one I decided to change the wheel. I decreased the size of the tank treads and added on two omni wheels, which increases the mobility. Because it didn't work out so well, I had to connect these two wheels with a chain, but because the chain was too thin, I used gears instead. Because the circumference of these two different wheels not the same, I switched one of the gears to smaller gears, so now this one moves faster. Here is the back of the robot arm, two high-strength motors, and gear ratio of small to large, which increases the torque. And here I added on two more larger gears and two more smaller gears to further increase the torque or power. But because it decreases the speed, I switched the two large gears to medium-sized gears. Here's the front of the robot, the elbow joint, with using the same principle. I added four more gears to increase the torque. And to further increase the torque, I doubled the thickness of the gears. Here's a pivoting joint, reinforced with a thicker gear. This is the front of the robot with an ultrasonic sensor, which measures distance. And here's the final robot. And here's another ultrasonic sensor in the front of the gripper. These are the program basics using the software EasyC V2 for VEX. What I learned. Structure, programming, and materials are the three main points I learned throughout this project. As you saw in the building process, the positioning, size, and weight of the gears and metal made a significant difference in the performance of the robot. Careful programming was important to improve the robot's precision during the autonomous period, and using only what was necessary helped conserve space, weight, and materials. This is my end product. This is the robot. These are the tank treads, omni wheels, ultrasonic sensors, gears, and the motors. What this robot is going to do, it's going to pick up this object and place it in a different location. My learning stretch. There are many factors that led to the overall learning stretch. Experience in the robotics club, along with the help of my community mentor and the time invested, led to our final product. During my research process and mentor meetings, I picked up bits of information on how computer programs run. I was also introduced to this unique program called Prezi. Challenges. Some challenges I faced include programming and structure. The logic and sensors in the computer programming are very complicated, and the positioning of the wheels and motors required frequent adjustments. So what now? From this entire project, I feel I've improved on my problem-solving skills, gained confidence, and delivering a formal speech. Proposing ideas is an important aspect in actually any career, and I believe this project has, to a certain extent, prepared me for my future career as an engineer. Thank you for watching.